Continuing with the probability of multiple events occurring, we have to think about dependent and independent events. And dependent events they have a chain effect, or independent independent events do not affect one another in any way. And looking at these examples, classifying your events, you roll a number cube and then you spin a spinner. Those two things have nothing in common. They're two completely different things, so they don't affect each other, so they would be independent. But when we talk about picking one flashcard and then another from a stack of flashcards, those two things are going to be dependent, and they are going to be dependent because the second card is dependent on what you pull first. Because once I pull my first card out of that, then the next card is going to be only one of 29 possibilities. So we've removed one of the possible options there. That's why that is considered dependent. And then this next one, you select a coin at random from your pocket, then you replace the coin and select it again. Are these selections independent events, and why? Well, you would first maybe think, well, because I'm doing it over and over again, that it might be dependent. But, well, since you keep replacing the coin after each selection, then each time you've reset it and it becomes an independent process again. So that's why that's considered independent, is because it's the same possibility over and over again, and it's independent because you're replacing it, okay? It's replace. Can't wait for the students to ask me what's that letter. Okay, so and then finding the probability of independent events. Well, we get a little bit more detail here, and the probability of independent events is going to be the probability of one event and another event, okay, is going to be the probability of one event times the probability of the other event. So when we have an and, looks like we're looking at multiplication. Good thing. And that is a and word, not an and sign. So we talk about at a picnic there are 10 diet drinks, 5 regular drinks, and there are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you will get a diet drink and fat-free chips? It would just be one bad day to get the diet drink and fat-free chips. So the event of, let's see here, the event of diet chips, right? Let's see. Okay, so the probability of selecting a diet drink, so we'll call this like event A, that is going to be, we said there's 10 diet drinks, so the probability of A is going to be 10 out of a total of 15 drinks, because we have 10 diet, 5 regular, so it's 10 out of 15, and I don't even need to simplify that right now, okay? And then the probability of event B, and that is going to be selecting our fat-free chips. Well, we had 12 regular chips and 8 fat-free, so that is going to be the probability of B, which is going to then be 8 over 12, or 2/3. And that is going to then be the probability of A, right? The probability of A and B is equal to the probability of A times the probability of B. And we have going on here, we said that the probability of A is 10 over 15, and the probability, goodness, I can't add, the probability here is going to have to be changed, because 12 bags and 8 bags is going to be a total of 20 bags. And then therefore we are going to have, that's going to be 4 over 10 or 2 over 5. Okay, and that is going to then give us a probability of, let's see here, multiplication, we multiply across, so we got 20 over 75, which is going to simplify down to 4 over 15, which is approximately going to be 0.267 or 26.7%. That's the probability there of pulling a very poor selection of diet drinks and diet chips at the same time. And then what is the probability of a regular drink and regular chips? Well, probability A of a regular drink is going to be 5 out of 15, and the probability of B, which is going to be regular chips, is going to be 12 out of 20. So we have 5 over 15 times 12 over 20 is going to be equal to, I don't know, 60 over 300 or 1/5 or 20%. There you go. There's your chance of selecting a regular drink and regular chips. As we start talking more into probability and the mutually exclusive events, what does that mean? We want to know, well, if they're mutually exclusive, can they happen together or can they only be done independently? So if we're talking here as rolling a standard cube, and before I mentioned that a standard cube we're just going to assume is a standard 6-sided die. And here we are looking at rolling a 2 or a 3. If we roll one 6-sided die, can we ever roll a 2 and a 3 at the same time? No. Since we were unable to roll two numbers at once at the same time on a die, then they're exclusive. Rolling an even number and a multiple of 3. Well, think about it. A 6 is both an even and a multiple of 3. Therefore, that is not mutually exclusive because they overlap. We can do them at the same time. So they are not mutually exclusive. Rolling an even number and rolling a prime number. Again, an even number and a prime number. I believe 2 is even and it is also a prime number, so therefore those two are also not mutually exclusive. And let's see here, not mutually exclusive. And because those can be done at the same time. And then rolling an even number and rolling a number less than 2. Mutually exclusive, right? Why would you think that it's mutually exclusive? Well, and is there an even number less than 2? There's no number less than 2, no even number less than 2, therefore it can't be done at the same time. And that is why it is not mutually exclusive. Okay, so at your high school, a student can take one foreign language each term, and then about 37% of the students take Spanish, about 15% of the students take French. What is the probability that a student chosen at random is taking Spanish or French? Okay, so finding probability for mutually exclusive events. Well, when we have an and or we have or, so we have the probability of one or the other, then that is going to be the probability of one plus the probability of the other, minus the probability of them happening. The overlap is what that's going to be, is where it's going to work out to be. So here we have the probability of Spanish or the probability of French. So we have the probability of Spanish or French, which we said is going to be equal to the probability of Spanish plus the probability of French, which is equal to 0.37. 37% is 0.37 plus 15% is 0.15, which is going to be 0.52 or 52% chance that you're gonna hit that. And let's see here when selecting those students. Now, this next scenario, so about 9% of the students will take Chinese. What is the probability that a student chosen from random is taking Spanish, French, or Mandarin, Chinese? Well, we again have ors, so we have the probability of Spanish or French or Chinese, and that is the probability of those added together. So the probability of Spanish is 0.37 plus French is 0.15, and then Chinese we said is 0.09, and that all comes to 0.61 or 61%. It's a probability of selecting a student one of those three languages, taking one of those three languages. And finding the probability here. Finding the probability, the number 1 through 10 are written on index cards. All right, so the numbers 1 through 10 are written on index cards and placed in a box, okay, symbolizing my index cards placed in a box. What is the probability that a card chosen at random has a number that is greater than 7 or even? Okay, so the probability of greater than 7 or even is going to be equal to the probability of greater than 7 plus the probability of even, and that is going to be, let's look at this, we have greater than 7, we have 1, 2, 3 numbers greater than 7, and we also happen to have, or even, 1, 2, 3, 4, let's do that in a different color. Even cards, 1, 2, 3, 4, 5. So it looks like that is going to be, we ended up with 0.3 plus, or 3 out of 10 plus 5 out of 10, which, no, 6 out of 10, right? 6 out of 10 cards were even. Okay, enough of that confusion. It's going to be 5 out of 10 of those cards are going to be even. Now going back up here, we have this. So we have the probability of our greater than 7 plus the probability of an even card minus. Here's where we have to look at this minus the probability of both of those things happening. So we could end up selecting an 8 and a 10 for either one of these cases. So we don't want to count it twice, so that's where it comes into the minus the probability of this and that. Well, the minus the probability of this and that is going to be, we have 2 cards that are greater than 7 and also even, so that would be 2 over 10. And that will give us then, if we look at it, a 3 plus 5 plus 2 over 10. Oops, minus 2 over 10, right? Minus 2 over 10, which is going to be the same thing as 6 over 10, or that is 60%. So there it is. We had to subtract the probability of both things happening. And you might say, well, why didn't we do it up here? Well, up here, it was minus 0, because in these previous examples up here, we didn't have any students that were taking both languages, in which case we would have had to remove them in that sense. But there you go. That's the probability of mutually exclusive events.